continuing from yesterday's notes. Okay. I'll give you a second to keep looking for the packet. It's a big packet. It has the genie in the front, if you are looking for it. It's like, there it is. What am I? Got the big genie in the front. Aladdin. This whole packet has Aladdin characters. Do you need another one? Right there. Oh, you got it? Okay. Okay. Aladdin, it's a really good movie. You should watch it. Okay. Dividing radicals. Like I said, it's one page and we'll fly through this. It's the same concept of multiplying, but we're dividing. So same concept. Think about what we did yesterday. Same thing, but we are multiplying. Okay. So when we're doing that, again, the quotient rule is just put it all underneath the radical. That's all. If you have a radical divided by a radical that has the same index of n, you just put them underneath each other. That's it. There's really nothing crazy about it. You're dividing under the radical. What must be the same? It's the same thing as multiplying. What must be the same? I just said it a little bit ago. What's that little n called? The index. Very good. The index has to be the same. If you have like the cube root of x divided by the square root of x, it's not the same. They're different. And then when we are dividing variables, a cubed, let me see if I can give you an example. A cubed divided by a, what would it be? How many a's are left? That's if you're multiplying. There'd be 2, and how did you get that? How did you get 2? What did you do with the exponents? You subtracted them. So you subtract. I was trying to get you to get it without giving you the answer. Okay? If you did a cubed divided by a, think about that for a second. I have 3 a's, and one on the bottom, one's gone. You subtracted the exponents. Because 3 minus 1 is 2. So that's where we're getting that. So just so you knew. That was just kind of an example. You didn't have to write that. So let's go ahead and get started here. Well, like I said, put it all under one big radical. Can someone tell me what 48 divided by 16 is? It is 3. That's it. We're done. You're just putting it under one big radical. You got to flip to the page, please. Okay. Now all the way out in front. Same thing as multiplying. You do what's on the outside and you do what's on the inside. In pink, what's 12 divided by 2? 6. Then we draw one big radical. In the inside, what is 60 divided by 5? 12. Please ask right now if you don't see where any of these numbers are coming from. I will explain it one more time. I'd be happy to. Because 12 divided by 2 is 6. 60 divided by 5 is 12. If it's underneath the radical, keep it there. If it's on the outside of the radical, then keep it there. Well, we can definitely break this down into 4 and 3. That's gone. What else can I break down? Good. The 4 into 2 and 2, and that's gone. Do I see a group of 2 because my index is 2? There it is. And what's left? What number? 3. Can anyone guess what this is going to come out as? Good. 12, radical 3. And I love how you use the term radical. Okay. 2. Yes. So I was just going to explain that. Remember, you multiply everything that's circled times what's on the outside. So we did 2, because it's a group of 2, times 6. Here's your 12. If you want to write it out so that you guys know that for your notes' sake, you can just write 6 times 2, radical 3, and maybe that'll make you see where that came from. We took this times this to get the 12. Any other questions? That's good questions. Okay, same process here. Please don't have a heart attack because you see letters. It's okay. If you notice, there's nothing outside, so I'm just going to draw one big radical. It's a square root, so we're just going to keep it there. Here we go in purple. What's 42 divided by 14? 3. I'm trusting you guys because I don't have my calculator. All right. Now, a cubed divided by a squared. How many a's are left? 1. And it's on the top. Now in blue, b to the 5th divided by b. Is it 14? Wait, hold on. Thank you. 42 divided by 14 is what?
30 divided by 3 is 14.
Yes, but we did 42 divided by 14, and it gets me 3. Okay. Now b to the 5th power in blue divided by, good, I have b to the 4th power. Look at what I'm doing. 3, this little guy, minus 2 is 1. 5 minus 1 is 4. Whenever you're talking about exponents, you're just subtracting them. Well, there's only one thing I can really break down, and that's the b, because remember what I told you. The power has to be bigger than the index, and that's the only one that's bigger. So, I have 4 b's, 1, 2, 3, 4, and I circle my groups. How would you write this out? Yeah. Go ahead. Was that a hand? No. Go ahead.
B to the second radical 3a.
Wait, where am I? Blah, blah, blah. B to the second, radical 3a. Beautiful. Because b times b is b squared. Or there's 2 groups of b. Do you like Smarties?
No,
Do you like suckers?
I don't like sweets.
Do you want to give it to someone?
Sure.
Okay. Are you feeling okay? He looks sick. Okay. So remember, I have 2 groups, 1, 2 of b. So b squared. Yes.
I'm still confused why you broke down the B. Why can't you just leave it?
You can't leave the b because the power 4 is higher than the index of 2.
Oh.
So you have to simplify it. You could leave it, but on like a math test or like an SAT or in the future, they're going to expect you to bring it outside because you can simplify it. Okay. Because most likely all of your exams will say like, leave in simplest terms. Well, that's the simplest it gets. We can't go any further. Now, this is something that, again, you've done in the past, but we're going to bring it back, and then this is really all we're doing today. We're going to probably go till 45, like I said. Rationalize the denominator. If you hear me say rationalize the denominator, all you're going to be doing is multiplying the top and bottom by whatever's in the denominator, and I'll explain what that means. Recall the meaning. There are no radicals in the denominator. You can't. Denominator. Mathematicians at some point in time said that we cannot have radicals in the denominator. I'm not really sure why. I'm going to look it up, but for some reason we just can't have radicals in the denominator. Just not the form that we go by. So, monomial denominators, we just multiply the numerator and the denominator by what that radical is. So I'll show you an example for D, and it's actually pretty easy. When you are multiplying or rationalizing the denominator, all you're doing is taking the radical that's on the bottom, and you're multiplying the top and bottom by it. And this is going to eliminate that radical on the bottom. That's why we're doing it. I'm going to zoom in. Okay. Questions on that one? Why can we do this? Does anyone know what this fraction really is? When you were to like simplify it, what number would you get? If you have, not 3, if you have anything divided by itself, what is it? 1. That's why you can do this. Because anything times itself is itself. Anything times 1 is itself. So again, like say I had 3 divided by 3, we know that's 1. Well, radical 3a divided by radical 3a is still 1. That's why we can mathematically do this. So here we go. We multiply straight across. That's all we're doing. So I have 9 radical 3a because you can't multiply anything. Think about that. This guy's on the outside, these are on the inside. So this one stays out, these ones stay in. Now here's the cool part. Whenever you do this, it's like canceling the radical. You are left with just 3a. And I will prove it to you in a second. I just wanted to show you first. Here's why. When you have radical 3 times radical 3, what do you get? What's in the inside? What's 3 times 3? 9. Then what's a times a? A squared. Well, when we break that down, I'm proving it to you. You don't have to write this. Look at that. I get 3a. I'm just showing you that if you multiply a radical by the same exact radical, it just disappears and leaves whatever's inside. That's the trick. We have one last and final step here. What is 9 divided by 3? 3. So I have 3 radical 3a all over a. There are no radicals in the bottom, so we did our job. If there's a radical still left, then it doesn't work out. Are you guys cold? You can close it if you're cold. I was just trying to get some air in here. Let's do it again. When you rationalize the denominator, you're multiplying by what's on the bottom to both the top and the bottom. So what am I going to multiply by?
Radical 2.
Divided by radical 2. I was just trying to get you to say it. The more, it's okay, the more you say it and the more you write it and say it in your head, I'm telling you, the more it'll stick. Okay? The more actively engaged you are, I'm telling you, the better you'll understand. Okay. Multiply straight across. 1 times anything is itself. So 1 times radical 2 is
Radical 2.
radical 2. See if you remember the trick. Elena's losing her voice, so everyone besides Elena. Radical 2 times radical 2 is just what? Radical 4, which is 2. Remember the trick. It's just whatever's inside. If you can't see that, that's okay. Let's kind of backtrack for a second. You do not have to write this unless you really want to. Or you could have multiplied straight across. Radical 2 divided by radical 4, which is what most of you just told me. You told me there was a 4 there. Well, we know the square root of 4 is 2, and that's why it becomes the same thing. So I'm trying to prove to you that like what we're doing in our heads and the trick is actually working. So this is our final answer, or this one. Do the same. We're going to change f and g to just say radical. We're not going to work with cubes. So letter F, can you just like fold that in, cross it out? There should be no cube there.
And the next one?
Yes. And for G2, we're not going to do cube roots. I feel like we've done enough in this chapter, and we'll come back to that later. So, like I said, you cannot have radicals in the bottom. You can't. It's just not mathematically correct. So what am I going to multiply the top and bottom by? The square root of 2. Good. When you do that, it eliminates the denominator having a radical, and that's why we're doing it. So we're going to multiply straight across. Who thinks they got it first? Smarties. I think I have Smarties left. Go ahead.
I did 3 square root 2 divided by 2.
Beautiful. Good, good, good. All right, and that's it for that one. Let's do it one more time. Now think about this one. It'd be silly to do this, but think about it. Before we do anything, always look at what the problem is saying. What is the square root of 9? 3. So if you can break it down like I did, 3 and 3, if you can do that, do it. Otherwise, you're going to find yourself doing more work. Obviously, if you did the radical 3 or radical 9 over radical 9, you'll still get the same answer. It's just going to take you longer to get there. Well, what is 21 divided by 3? 7. Okay. Questions? Look at that.
Call that.
Called it.
Play lottery tonight.
I should play the lottery tonight. Okay, let me just check something really quick. I wanted to see something. Do you feel comfortable with what you just got taught, or do you feel like you need to do more problems?
I'm good.
You're pretty good? Because if you do, then that's why I gave you that extra worksheet so we can do more problems together. No? Okay, with that said, here is your homework. It is 10 questions, and you have, like I said, let's see, 55 times, you have 23 minutes left. 22 minutes left in the 7. I always get confused with the 8. Now, it looks like a packet, but it's not. It's 10 problems. The last page is the key, so you can check your answers. Okay, so the back page is just the answers. It tells you what the actual answer is. This way, when you're doing the problems, you can be like, oh crap, got that wrong. Maybe I should ask a question. Okay, so 1 through 10 is your homework. 1 through 10 is your homework, and you have 22 minutes to do it. You can work with a group member, or you can work alone. It's this one. That one cost. That was going to do extra. Okay, so we're going to keep going. So, good, right? Good. Now, again, you would have realize that so we have 21 times 3 divided by 9, because we have to keep. Yes, so like this one, because you can simplify the radical, you can't simplify it. Oh, right. Yes. So then 21 times 3 divided by 9 is 7. Yeah. It's just that's the harder way, the longer way. Always just try to recognize first. Remember this back page, if you look at it right now, I did that for a reason. Took me longer to do so, but gave it to you. These are the answers. If you just write these answers, you're not getting credit. It's not how it works in math class. Okay? So please do your work and try. And if you don't get number 1 to be 1 over 10, please call me over or ask a group member how to do it. Chromebooks are closed. You shouldn't be on them. You don't need them unless you're working on a calculator, which GoGuardian will tell me you are. Okay? I'm just trying to get you to understand the math. This SAT is pretty tough.